Scene script. Have you ever wondered how we could breathe on Mars? It's a question that has occupied the minds of scientists, space enthusiasts, and dreamers alike. The red planet, with its dusty surface and ethereal allure, beckons us with the promise of exploration and discovery. Yet it poses one of humanity's greatest challenges, the quest for oxygen. On Earth, we take for granted the abundance of oxygen in our atmosphere, making up around 21% of the air we breathe. But Mars, it sings a different tune. The Martian atmosphere is a thin veil, with carbon dioxide taking up a whopping 95%. Oxygen? A mere trace at less than 1%. This stark contrast underscores the magnitude of the problem at hand. How do you breathe in an environment where the vital gas you need is virtually non-existent? The challenges don't stop there. Mars's low atmospheric pressure, about 100 times less than Earth's, makes it even more difficult to extract the scant oxygen available. And let's not forget the Martian weather, with its notorious dust storms and freezing temperatures, further complicating matters. For a long time this conundrum seemed insurmountable. The idea of setting foot on Mars, let alone living there, seemed relegated to the realm of science fiction. But as the saying goes, necessity is the mother of invention. Today we stand at the threshold of a new era, where scientific discoveries and technological advancements are starting to chip away at the seemingly impossible. Scientists are developing ingenious solutions, harnessing the power of chemistry, physics, and engineering to turn the Martian atmosphere into a life-sustaining resource. From experiments that convert carbon dioxide into oxygen, to advanced life support systems that recycle air, the landscape of Martian exploration is changing. The prospect of breathing on Mars is no longer a distant dream, but a tangible goal within our reach. The quest for oxygen on Mars seemed impossible, but scientific discoveries and technological advancements have started to change that narrative. Our journey to obtain oxygen on Mars begins with the evolution of space technology. The history of space technology is a chronicle of human ingenuity, beginning with the earliest telescopes. In the early 17th century, Galileo Galilei's telescope gave us our first glimpse into the cosmos, revealing a universe of celestial bodies beyond our wildest imagination. But we didn't stop there. Our curiosity and thirst for discovery pushed us further. In the mid-20th century, the space age dawned, a period marked by intense exploration beyond the confines of our planet. This era was sparked by the launch of Sputnik, the world's first artificial satellite by the Soviet Union in 1957. This small beeping ball was a simple device by today's standards, but its impact was profound. It set the stage for the Great Space Race, a competition that spurred rapid advancements in technology. In the following decades, our journey into the cosmos accelerated. We sent humans to the moon, rovers to Mars, and probes to the farthest reaches of our solar system. Each mission, each step, was built upon the knowledge and technology of those that came before, creating a cumulative wealth of understanding about our universe and our place within it. One of the pivotal moments in our quest to understand Mars came with the Mars Reconnaissance Orbiter. Launched in 2005, it has provided us with detailed images and data about the Martian surface and its atmosphere, more than any mission before it. It revealed Mars as a world of contrasts, with towering mountains, deep canyons, and vast deserts. Most importantly, it confirmed the presence of carbon dioxide in the Martian atmosphere, a critical finding for our pursuit of oxygen on the red planet. These advancements paved the way for a revolutionary solution, turning the red planet's carbon dioxide-rich atmosphere into breathable oxygen. This is not the end of our journey, but rather the beginning of an exciting new chapter in our exploration of Mars and the wider universe. The evolution of space technology has brought us to this point, and it is this same spirit of innovation that will guide us into the future. Enter MOXIE, a golden box with a groundbreaking mission. Aboard the Mars 2020 rover, MOXIE, or the Mars Oxygen In-Situ Resource Utilization Experiment, is a technology that seems like it's straight out of a science fiction tale, yet it's very real, and could be the key to human survival on the red planet. MOXIE's aim is as bold as it is simple. It seeks to convert the copious carbon dioxide in the Martian atmosphere into oxygen. The process is not unlike a tree absorbing carbon dioxide and releasing oxygen here on Earth. But how does it achieve this mechanical photosynthesis? The golden box inhales Martian air, which is about 95% carbon dioxide. It then compresses and heats this air to around 800 degrees Celsius. The high temperature breaks down the carbon dioxide molecules into their constituent parts, carbon monoxide and oxygen. The oxygen is then isolated and measured while the carbon monoxide and other gases are released back into the Martian atmosphere. But what does this mean for future Mars missions? Well, MOXIE's success could significantly reduce the cost and complexity of human exploration of Mars. Instead of lugging vast quantities of oxygen for life support and rocket fuel all the way from Earth, astronauts could use MOXIE or its descendants to generate oxygen on site. Imagine the possibilities. We could establish self-sustaining outposts on Mars. Astronauts could stay on the Martian surface for extended periods, conducting research, exploring new territories, and perhaps even laying the groundwork for permanent colonies. But MOXIE is not just a scientific experiment, it's a beacon of hope for future Mars explorers. It's a testament to our ingenuity and our relentless pursuit of knowledge. And most importantly, it's a stepping stone towards a future where humans are not just confined to Earth but can thrive on other planets too. MOXIE is not just a scientific experiment, it's a beacon of hope for future Mars explorers. As we stand on the brink of a new era in space exploration, what does the future hold for oxygen on Mars? This question sparks a vision of a future where humans venture beyond the confines of our blue planet, setting foot and indeed living on Mars. Our quest for oxygen on Mars is an essential step in the grand journey of space exploration. The potential developments and challenges in producing oxygen on the red planet are considerable. Yet, they hold the promise of transforming the way we approach life beyond Earth. Consider this. Future Mars missions could be revolutionized by advancements in oxygen production technology. Imagine, if we could generate enough oxygen on Mars, the need for carrying hefty oxygen supplies from Earth could be significantly reduced. This would not only make space travel more efficient but also more sustainable. But like all great endeavors, this too comes with its fair share of challenges. Mars' thin atmosphere, predominantly comprised of carbon dioxide, presents a formidable obstacle. Harnessing this sparse resource to produce oxygen requires innovative solutions and unwavering perseverance. Perhaps one day, we might even see terraforming, the science fiction turned science fact process of transforming a planet's environment to make it Earth-like. This could mean engineering an entire atmosphere capable of supporting human life. With each stride we make in technology and knowledge, the possibility of a sustained human presence on Mars becomes increasingly tangible. It's not just about stepping foot on Martian soil, but about carving out a place for humanity amidst the stars. The future of oxygen on Mars is, in many ways, a reflection of our own future. It's a testament to human ingenuity, resilience, and our ceaseless longing to explore the unknown. As we continue to push the boundaries of our knowledge and technology, the dream of breathing Martian air moves ever closer to reality. So, are we ready to take our first breath on Mars? We've journeyed together through the evolution of space technology, delving into the incredible Mars Oxygen In-Situ Resource Utilization Experiment, or MOXIE. We've glimpsed into the future of oxygen on Mars, a future where we may no longer be bound to our earthly home for survival. Each discovery, each technological advancement represents a step closer to making Mars habitable for humans. It's a testament to our insatiable curiosity and our unyielding spirit of exploration. It's about pushing boundaries, testing limits, and daring to dream beyond what's known. This journey isn't just about extracting oxygen on Mars, it's about the human endeavor, the quest for knowledge, the thrill of discovery. It's about us, as a species, stretching our arms towards the unknown, reaching out to touch the stars. The question of how is slowly being answered. The question now is, when will we take our first breath on Mars?